Okay, problem 3, a plane is flying horizontally at an altitude of 2 km. So let's say this is a plane. Okay, and let's say this is a ground. So the altitude is 2 km, right? So this altitude is 2 km. And it's flying at a speed of 800 kilometers per hour, and it's flying horizontally. Okay, it's flying horizontally, and the speed, okay, let's use this. So its speed is 800 kilometers per hour. Right, and it's flying directly over a radar station. So initially, it is right above a radar station. Okay, it's right above a radar station. And find the rate at which the distance from the plane to the station is increasing when it is 3 kilometers away from the station. So originally, the distance between the plane and the radar station is 2. Okay, after some flying, for example, let's say the plane is here right now. Okay, so now this is plane. Initially, it was there, and now the plane is here. Okay, and now the distance from the plane to the radar station is 3 km. Okay, so we have a right angle triangle here. And find the rate of change, okay, of the distance from the plane to the station. So what's the distance from the plane to the station? Okay, it is the length of this, right? The length of the hypotenuse. So let's call this distance d. Okay, and let's call the horizontal displacement of the plane h. Okay, so first, because it's a right angle triangle, we can write down this equation very easily. 2 squared plus h squared is equal to d squared. Okay, that's the first equation. Then you also know, because of the speed of the plane is 800 kilometers per hour, so dh over dt, okay, it's given, it's 800. And the question wants to know what is dd over dt, right? So again, you already have this 4 plus h squared is equal to d squared. You just need to differentiate both sides by t. Again, do notice that here you need to treat h and d as functions of t, okay? They are unknown functions of t. For example, this d, right, is maybe t squared plus 2t, maybe, okay, it's not true. Or maybe d is like sine t, like square, plus e to the power of t. It doesn't matter. Anyways, d is a function of t, and it's an unknown function of t. You don't know the expression, okay, between d and t. But because we know this, so when we differentiate it, we need to use the chain rule. First, let's differentiate a constant. Differentiate a constant, you get 0. And then you differentiate h squared. First part, you get 2h. And the second part, because h is a function of t, right? So you get dh over dt. Okay, then the right-hand side, d squared. First, you differentiate it, you get 2d. And then d is a function of t, so it is dd over dt. Okay, it is dd over dt. And now, h is, right? So h, what is h? Okay, we have 2 here, 3 here, h here, so it's easy to get h, right? H is square root of 3 squared minus 2 squared. It is square root of 5. Okay, so it's just 2 times square root of 5 times dh over dt. It's 800, right? It's 800 here. Times 800 is equal to 2 times d now is 3, times dd over dt. Okay, then you do the calculation, you get dd over dt is, okay, you can do the calculation by yourself. Okay, it's going to be 800 square root of 5 over 3.